Okay, here we are back online. Welcome everyone. I'm sorry I'm a bit late tonight because I was working on something else and I haven't seen the time passed. But here we are again for our little Codevember session. And it's Codevember 20. Yeah, 20. Okay, 20, yeah. 20 little guy. He made a lot of kilometers, this one. And this is when I start the stream that my little guy are freezing. So yeah, I want to make a new one. So yesterday we made our little guy with a lot of I think we had a crash on Unity. Do you want to save the change? Cancel. Okay, so yeah, it was only a problem of memory, and I think because I'm okay. Let me try to just close some elements. Okay, back to it. Yeah, so yesterday we made this little cute guy. I think it's cute. It was inspired by the work of Casey Farina. I've showed you his work yesterday, and it was really interesting. Instagram. So what I want to make today is, let me check, because we need to know what we want to do before doing anything. So yeah. Oh my, I just seen the new work from Etienne Jacobin, which is amazing as usual. Yeah, so I was thinking about something. I've seen some work. Where is it? Where is my... Let me check. So there is two references for this inspiration from tonight. Yeah, I have two references in fact, but I think the second one will be for tomorrow. So yesterday I was talking about maybe playing with butterfly, following the shape, so basically going with the same elements that this one. But I might have a better idea. Not sure if it's better, but an idea. Of course, an idea. So my first reference would be from, I think this is... Yeah, Lutzkick. Yeah, Lutzkick. Okay, this will be my first reference. Lutzkick are playing with multicolored particles from a while right now, and basically it's a lot of work about moving particles, etc., etc. So it's really interesting. And the one I've seen is, I think this is this one. As you could see, we have this moving particle, but we'll also have some lighting on the shape. So look like it look like for me it's a sphere signed distance field. So basically we have a little distance from the... We have blocks of particles and we have a sphere in the middle of it, and we compute the distance from the sphere to each particle, and by using a modulo again in order to have a pattern, you could have the you could say on this for the particle which are on the distance from, let's say, a minimum to a maximum, we will have a color, and for another minimum and maximum another color. So it depends on the range. So I think it could be really interesting, and what I thought is not not working, especially with side distance field like that, because as you can see when the camera moves, we can really see that the particles are basically changing the color based on the distance from a sphere which is inside. But maybe on screen position, so basically when the camera changes position, the color will follow, so it might be really interesting, some kind of like a projection. So this is the main idea. Another reference I want to show you, because the rock from this person is really interesting, but there is another man I want to show you, another creator. I think it's Maxim Z. I'm sorry for the name, Maxim Zetkov, which is one of the motion designer founder of Media.work, which is basically an amazing studio with a lot of experiments. And Maxim has made a lot of great experiments. This one is really interesting, especially because it's a way to experiment with noise. But he's really famous for one work. He's also made with particles, and he works a lot with particles which seems to be glued together and sometimes stretch and explode. So it's really, really interesting. It also works with distance field. As you can see now, it's some kind of city full of particles, and the color change depending on the distance from an element, an invisible null elements. So it's really interesting. And this one also is really amazing, because you can see the particle changing their position but revealing a shape directly inside. I really love the way it's working. The art direction is amazing. And one of his famous work is, I think, this one, which is a big structure like a Remanta. In fact, you could see the way it's waving a little bit like a Remanta, because it's only wave more on the extremities and on the inside, and you have some colors also, and it was really, really beautiful. Yeah, he made some work also on Unity. So here's another view. So you could see really as I said, the Remanta behavior, so the wings opening and then going back. It's really, really amazing and beautiful. This one also, when you can see the light flowing across the particles, it's a beauty. It's really a beauty. This one, yeah, this one also, you could see the way I was talking about the Manta look. So this could be an inspiration, but I think with that you don't know where I'm going because that's the idea. I really don't know where I'm going either. So yeah, this behavior might be really interesting for the color elements, but what's about our little guy we have on the bottom? So let's rerun our little guy again. I don't want to lose too much time on this. I think I will try to do something easier this time. I hope it will be easier, because every time I say it will be easier, I'm lost in some weird math problem or bug or anything. But yeah, yesterday during the stream we've tried to sequence our little animation like that, by saying that maybe we want to follow a target, then go to a curl, then follow a target, then go to a curl, then follow a target. It was not quite interesting, because for the curl it would be to explode and then go back, and it was too many elements. But I thought about one thing. Let me explain. The way you can have oh, my voice seeking its own path. Okay, great, sorry for that. Yeah, so what I was so some kind of color particle and some of little sand collapsing, etc., etc. So yeah, because I'm a bit late, Of course, I want to reach to make an ID which is simpler this time, but can be powerful as a visual. But it's Friday, so I think maybe because we have 22 p.m. maybe we will end at 1 hour. Maybe we will reach the 2 hour coding element. So I don't know. So let's go back and let's try that. Okay. So first of all, as usual, you know what will we need to do, which is save our little scene here as a new scene, which will be our 1120. Shazam. Okay, then and again, and we need to do all the little tricks we've made previously, which is duplicating every element. So because I have my complete shader here, and this one can be really easy to duplicate, so it's okay. Then the GPU mesh controller and the controller. Okay, so as you could see, 5 is really big. So first of all, again, let's comment this part and try to find a nice value for every element here. So as you could see, we have something really different. So let's fix everything to 1 and 1. Okay, again we would first fix everything to 1 and 1 here, and also 1 and 1 for the mass. So we would have something of 1. So as you could see, now we have a jiggly system, of course. So desired by the edge force, it's okay, and this is also edge speed, it's okay, and this is the max speed. So it's not the max speed, but it is the edge speed, because okay. So let's try that. So let's find something between a mass of 2 and 4. So now I will dividing everything, so it will be, I think, yes, slower. So this is good. Then we could increase the min force and the max force, so let's say 4 to 5. Okay, and I need of course to change the speed, so let's say speed max of 5 in order to be able to reach the position quickly. Okay. So the steering behavior seems good for me. But the force seems a little bit tricky. And if I get rid of the mass part, this is much more interesting or not. it's strange because each element has the same behavior. So why do we still have this little problem? Yeah, this is too big, so 2 and 2. Zero 5 0 5. We have this little the edge force is something between 1 and 1, so this is not a problem. So let's use the same, instead of using the lerp, let's use the proper value here, just to be sure. And get rid of the damping. So 1 and 1 with the delta time seems to be bouncing a lot, and we haven't used the mass right now. If I divide by the mass, which is it, I think divided by the delta time create this kind of randomness into the position, you know. So yeah, if the max speed is 5 and the max force is 5, now we have something with more. It's okay, but it's bigger. The randomness is really too big. I don't understand why. And if I invert this, we still have this randomness. Does it come from this? Do we need to simply make the same thing we've made yesterday? Something like that. I'm thinking the delta time is the problem. Yeah, you could see it's better now by simply multiplying by the max force instead of having this problem. But of course this could be the proper value. So let me think about that. I clearly think that the problem comes from the delta time. It's kind of interesting dumping everything from the delta time because you will scale down the value. Okay, not a problem, but what I think is because the delta time might change. We could see it here, for example. Let's try to debug this. So debug.log, and we will take the time.delta time because it's moving and we're dumping the velocity. Of course, sometimes it's smaller, sometimes it's bigger, and we have this kind of jiggly system. So this idea I found on internet is interesting. It might be a way to be sure to dumping everything, but as you could see, it's changing here. So sometimes we're going to 02, 07. So this might be our problem. So I'm more thinking about, instead of using the delta time as a dumping system, simply using a fixed dumping of 001. So we could still use a value upper to 1, but now you see that we haven't our problem anymore, and we could use a system based on that. Okay, so yeah, let's put the max force to 2 and find something that might be interesting. Okay. So speed of 1 is okay, but max force, as you could see, it's okay for 1 for the max speed, because we're dumping everything. Then we have this jiggly value again, and I'm really not sure about this one. Okay. Okay. So the steering behavior is interesting, but we need to add some max force. So the speed is enough. This is when usually I'm saying that I really don't like physical system, when you have this jiggly element. Okay, well, let's go back to our main behavior system, which was something like that. Okay, this is more a problem of the damping, so it's okay right now. Then the max force could be something like 5, max speed of 5 for example. Okay, we might end up with something which is really mess up, but I'm starting to like the way it's changing on the foot. Could we damn this by that in order to be able to let's say having a more powerful force for the steering behavior? And now we could increase a little bit this to change the velocity of each particle. Okay, let's check that. Again, it's a strange behavior, but what happens if we don't damp the steering? You could see if we don't damp the steering, we have this. Okay, so now if we simply take this and multiply by this, we have this elastic system. But I think we might be better multiply the vector directly in order to keep their position and to have something like more yeah, this is what we had yesterday. So yeah, this is the main problem. Okay, so the main problem comes from the fact that we are normalizing the vector and then we are multiplying it. So when I'm moving my leg, okay, so this is the upper leg and this is for example the foot. Okay, so my leg is moving less for these vertices for the knee, for example, are moving less than the foot, which is going with that more movement. And we simply take all the vector normalizing, so all the vector are the same size, and then we are multiplying by the max force. But which create this kind of really bouncing effect on the foot because the foot are moving more than the knee. So if I don't want that, I could simply just multiplying the vector instead of taking the normalization, and we would result with something with a little bit elasticity, but less than that we had right now. and we could take the max force and the max speed here. So let's retake this here. So basically we are going to the same system we've made yesterday. So this is okay. So now we can, maybe if I put a max force of 5, you could see what's happened. So with 5 we are simply stretching everything, so it will be bigger. So 2.5 and maybe let's say something like 1.5 and check what's happened if we use the edge force instead of this. So now we create a little bit of randomness into it. So now we have a little bit of stretch, so not a problem. Although it seems that the max force might not be enough. So let's say 3.5, because we want to have a full body movement. So 3.5, which is a big stretch. Maybe we can move something like from 2 to 3, you know. So 2.5 seems to be a good stretch. So going a little bit. Okay. So now it's a little bit stretchy. So okay, why not? So we can change a little bit the speed. So let's put the speed to 10 just to check. So 5 is interesting, but let's check the speed to 10. Okay, did I use the speed? Yes, I used the max speed here. This is a way of damping everything. So I still have my damping here, but I might be able to simply say remove this damping, but I think it would be changing anything. So yeah. If I put 1 to the max speed, let's check what's happening. Nothing. Okay. Why does anything happening to the max speed? I think because we haven't reached the max speed. I think this is why. Okay. So the max speed is this, and if I put something like 8, let's try to have something more interesting. I've re-put the max force and not the edge. That's why. It's the edge force I need to use. Okay. Because everything has the same force. So now we have our little elements that are moving, so why not? If I get rid of this, you will see what's happening. Okay, so now we have some kind of bouncing effect. So let's say we want something like this, max force between 20 and 40. Which is quite big, 20. I'm trying to find a way of having some max forces. It seems to be less bouncy than I wanted. So the edge force is this, which is based on the ramp. So we're multiplying this, not a problem. Do we use the edge force elsewhere? No, only here. So I think this is enough. Okay, we have an error. Somewhere I've made something like this. So okay. And now we have some kind of little bouncy elements. Let's reactivate the scale because we need it. So of course everything has the same scale, so it's not really let's say the mean scale is 25. Okay, so this by this, if we are going down, do we retrieve some jiggly elements? Okay, looks a little bit good for me, not too jiggly, but we still have some jiggle part somewhere, so why not? So it seems to be okay. We could add our little curl scale, which is it. So let's try that. Maybe the scale is a little bit too much. The movement is good, but the scale is a little bit too much. So yeah. So now it's kind of more interesting. So 0.1 and let's say min size of 0.05. Okay, this is the kind of little bouncy man I wanted alongside a little cloudy man. Okay, so now I can go back to the second part. So here it is, and going back to the falling parts, and then we could focus on another things. Okay, and then going back. Okay, so now we have some kind of problem with the force. So the falling seems to be okay, as you could see. The fall is quick, and we have divided this by the mass, of course, but right now let's try not that. Maybe we'll not use the mass, in fact. Okay, so the max force is here, so maybe I need to multiply this by the edge force to be sure. Okay, and now dividing by the mass. This is really big. Let's say minus 0.5. Let's reduce a little bit the fall. Okay, and let's reduce this force by multiplying by 2, for example. Okay, go back to this, don't need this. So we have the bouncing, but it's really too much. You can notice here the steering behavior, we haven't clamped it. So if this is too much, so it seems, of course, we are not on the proper, or the position when we are falling seems to be up. I'm not sure, but no, it's on a proper position. Okay. So this is interesting. I think the problem is here. Maybe we could define something like that. Maybe we could change something like max deviation, which could be something like, let's say, I want in fact to go up and deviate a little bit on the x and y axis, so maybe I want to scale a little less the x and y axis than the x and z axis than the y axis. So let's say I want to move to 0, 1 to have just a little bit of 10% of this. So I could simply say that and multiply by the max deviation. So this would be our little random vector. So I would not need to multiply it. So now you could see it's more interesting, and we can scale it up a little bit. So for example, if I say multiply by 2, now I could go up and then it would change. Okay, and now we have the bouncing, so that's interesting. So now we could say something like the edge force could be a way to change a little bit the force. So some will be bouncing higher and some will be bouncing okay, which could be a little bit too much. So let's go back here, we will use this again. So plot max in gravity would be something like that, but instead, so I've used something like 2, we've seen it's something interesting, but maybe 5 only. Oops, this is going here. So you've noticed that it's in 5 is interesting, but let's say 1.5 and 3.5. We have a lot of elements, so of course (1.1) and 2.5. And also I think we should need a little bit of resistance, because now the bouncing is really like that, but we need to add a little bit of a friction, and the friction was something we've made in the 17. I think we have it. Yes, we had this friction here. Remember, the friction was the velocity multiplied by -1 multiplied by some kind of, you know, a constant. So this was some kind of a friction, not really the friction, but it was some kind of a friction. So we could say friction. Let's use this same, and we could say acceleration is equal to friction. So this is a way to decreasing the velocity when we reach the when we bounce, you know. Or do we, I think we've put the friction of the, yeah, put the friction every time. In fact, it's not only when we touch the ground, but the friction is some kind of a constant force. Yeah. So I've said something like that, but might be something like that. In fact, I need more friction. And now you could see what's happening. Okay. Yes, this was the idea. Okay. Let's reduce the gravity a little bit and see if it's correct. Yeah, it's more interesting if we reduce the gravity. You could see how the bounce is happening. So basically we can change this a little bit and say this, and I just found out that we haven't had any sound on the stream, so let's go back. Okay, I think I've reduced it a little bit too much, but 0.5 here is interesting, and I think too, because I want to have some elements going really high. Okay, we could also increment a little bit the deviation in order to have less something going only on the ground, but deviating a little bit more. So this is something which is really interesting with the force, so you will always need to tweak all the value to find the proper one for you. It's interesting. Of course, I have changed the camera quickly. You can see the problem with the reflection, but basically, I'm really interested by the way it's moving. And we have again 10,000 of particles. So, and it's physics particle. So you could see if we are going with less particle, it will be bigger to compute, and then we have this problem because we are based on the frame. So but we could, I think we could say something like that. reducing our velocity directly here might be a solution if I want to work with. So I'm starting looking into the friction might be. It might be interesting to change a little bit this, because I create a random reflection vector, but I think we could use the magnitude by the velocity. So for example, we could simply say the length of this. Okay, so let me explain why. Basically, each time we've oh, hi, thank you for the for the smiley. Basically, the problem with saying something like that, so I'm creating a reflection vector with a random direction for the x and z. Okay, no, not a problem, of course, but I'm not taking part of the fact that the friction is applying, because I'm rewriting a vector with a pure component on the y-axis, which is 1. So every time the ball is bouncing, it has this, it takes the same force for bouncing up. So a way to change it might be simply saying that. So instead, usually when we want to apply the friction, we simply say that we take the velocity component and we simply invert it, you know, we simply say something like that. Okay, why not? But we try to apply also force. So if I'm inverting this inverting the force, yeah, it might be working, because I don't have a y component on this force. So unexpected position where, yeah, I forgot the semicolon here. Okay. Yeah, so now we can see the friction applied to it. So if I want also to change, I can on it. In fact, if I want to slow down the particle, a trick might be to say something like that. Multiply by the norm time. I think it's not a good trick, but it could be a way to change the bouncing system. No, it's not working. Okay. Okay. So this is working, not a problem. Okay, this is good for this part. Let me check. 35, 22, we have this random, we have this deviation. The deviation is quite interesting, so okay. Okay, I think we are good for this part. We might now work on the shading part. this max gravity might be a little bit too much. Now it might be a little bit too much. We've used it in order to increase the speed a little bit, but as you could see, it's more interesting right now. So let's change this a little bit. I'm really trying to tweak the force, in fact. So we have this kind of stratification, and maybe we can get rid of that by trying to taking the length of the velocity as a bouncing element. Try to increment the bouncing vector. And let's say instead of that we will divide it by 0.25 to reduce it a little bit, because we're scaling it. No, it's not really interesting, so let's go back with our little guy here. Okay, perfect. Let's start the shading. So now every particle are falling at the same time, but maybe we want to change this. So again, we can use our little things here, and you will see that the offset is really big. So now it's only some parts that's going down and going back. So it's too messy right now, but what we can do is simply offset just a little bit the elements. So maybe, just maybe, let's take the same time, try that. So for example, we would take something like, I want 2 seconds, and let's try to offset just a little bit, so not too much. For example, only 2 by 2 1. And then I will do the same for this one. I will use another random for the same value. The idea is just to offset a little bit the elements, but keeping everything yeah, you know, just by using the offset, we just simply change a little bit the range of the animation, but not for all of them. So 2 second 25, 2 second 25. So of course, because we offset a little bit the time, over the time it will not be the same, but we still have this thing, so it starts falling down and then it's recomposed. Oh no, as you notice, the more it's fall, the more we change everything. So can we change this a little bit? Maybe by just offsetting the time. and thinking only this might be enough. We have the same value, but we're just offsetting the time, so we've reached the same value each time. Okay. So now if we offset this like that, we could use in fact this value, which seems to be a better random. So now we have a constant animation, so this is better. Okay, so times to work on the shading parts. So let's go back to that. We have the ramp, so this is good. Let's just start with the ramp. Let's use, for example, this ramp, or this ramp, which is beautiful, I think, or not. I'm not sure. No, this one. Okay, because I have more data in this one. Okay, so the main idea was to try something maybe using the screen projection, which is, no, I'm in the compute here, so this one is okay. So this is it. So I have the screen position, which is this position, this is that. So this is the screen pose. So how can we achieve that? Basically, this is the screen position. So this is in pixel position, of course, but this is now in normalized position. So if I'm saying something like that, float circle SDF, and I say something like the length of this vector, so I will need to offset a little bit, but if I think the length of pose, okay, and I would say something like, I will override everything, okay, so I would say that the ramp is basically, we use the albedo ramp, but as the x value we will use the circle SDF. So basically, by taking the length of the position, which is in normalized value, so 0, 1, I might ending with some kind of circle from the bottom left, I think, because bottom left is 0, 0. So if I say something like that and I say all.albedo is equal to ramp, so I'm rewriting this and I say this is equal to ramp. I'm not sure if we would see something, but let's try that. So I could have some gradient from, as you can see here, we have a gradient from a view, a corner, which seems to be the bottom left, I think. Okay, let's get rid of everything else just for the moment and try to only work with the albedo. So if I want to go from the center, I need to take the position and offset it to the center, and the best way to do that might be simply by taking the position, multiplying by 2 minus 1. This will take the origin, which is on the bottom left, and by saying that multiply by 2 minus 1, by remapping between minus 1 and 1, I will take this center to the this corner to the bottom left, to the origin to the bottom left, to the center of the screen. And of course I will not have to manage the aspect ratio because I'm already on squared Okay, now you can see what I mean by this kind of projection. So this is not really perfect, but this is kind of interesting also. So let's now try to move everything else into a 3D sign distance field, and for that we would need something else. So I'm not sure I have a sign distance field in the script here, but maybe I have it. Yeah, 3D shape. Okay, so I will need to add this to my shader. So its name is SDF 3D shape. Okay, not 2D, 3D. So the main idea is basically trying to change these things. So let me show you. So here we've made a sign distance field in 2D. So basically we're taking the pixel position on the screen space and we are setting the color on the ramp using this position. So that's why we have this circle here. So this is the main idea. If I want to create something quite interesting, for example, might be something like that. Instead of taking this, maybe I can use a fraction. Yeah, I could use the fractional part. So I could use the fractional part of this value multiplied by 10. So I will have 10 layers of repetition for the color. So you could see, yeah, or you could see the layer system I mean. So for now it's not really interesting because it's basically putting a color like a mask directly on the screen. But what I want to do is basically using the same system but in 3D. So basically computing the sign distance field for each particle from a sphere which might be on a different position, for example on a 0 0 for example, which is the ground, and then we can have some kind of irradiating system. Okay, so let's go back to that. So in order to take this and putting everything not into a 2D system but into a 3D system, so this is our 2D system, we will simply change a little bit these things. So the position, we have it as a position because in the compute shader we also have put this position in this, okay, in the transform mat. So this is okay, we have the color is okay, and here we don't use any value. Okay, we have the oppose here, which is not the position, but this is the original position, I think. So let's open this vertex shader, okay, and let's change this vertex shader by the 20. Okay. And now what I want to do is simply bind the actual position from the vertex shader to the fragment shader. So remember that the position is the last, this is it, so this is the last value, the last column of the transform matrix. So I will put it directly into the oppose, so I will not have to do anything else. So this is props dot transform matrix because the transform matrix is an element from this. Okay, as you could see, we have an oppose, so we have the transform matrix. So I'm taking the props, which is the mesh property, and I need to set it a fake 4, so let's use that. So now I'm putting the position of the particle directly into the oppose data, which is available directly in our shader. So I could say foo3 pose is basically equal to in.oppose.xyz. Okay. Oh, and remember, in the oppose we put the original position, we have a random value, so maybe we in the vertex shader we also put props dot oppose the w, because in order to retrieve the random we use this random value inside our compute shader, so we need to retake it and to be able to retrieve it in the compute shader. You need to remember every time you make something a different modification into your structure, such your structure is shared, it's created in the CPU, then it's bind to the GPU and it's shared between the compute shader and to the vertex and fragment shader. So it's important to get the same value every time and not overwrite anything else. So yeah, in .oppose.xyz, and now I could use a sign distance field, which is basically it's taking the position, the radius we want to use, and here I have an index. It's not, we will not use it here, but all this 3D sign distance field are basically used from a lot of my old remarching shaders. So the index helped me to manage the index of the shape in order to have different texturing when we use rematching. So but here we don't need it, and it will return me a float too, so a vector with two components. The first one will be the sign distance field, and the second one basically is simply the index. So I would need to say float sphere SDF is equal to the SD sphere dot x, because I only want to retrieve the sign distance field and not the index of the position. Okay, the radius, so the radius, let's say a radius of 0.5 for example, or 2, let's say 2, let's say 1 for example, to try 1, and we will use an index of 0. It's not necessary, but okay, so I think it's a float. Yeah, the index is float. I keep everything as a float. Okay, so now that I have this, I could use again this in this little system here, but now I will use the sphere distance field. Whoops. Okay, and I could reactivate everything in the hope it will work. Does it compile? I think so, but let's check. No, unexpected token. Oh. I'm in a vermage. Okay, so redefinition of pose. Yeah, of course I've redefined this. We can comment all this discard method right now. Again, I will try to clean everything before putting all the project on GitHub. Okay, so let's try that. Okay, so now you can see basically it's working, but you can see something else. You can see we have this, so we have a repetition. Why that? We have a repetition because basically the position we are taking here, so we're taking the sphere position from the center of the scene, from 0, 0. Okay, so because all the particle or the position, if we take a vector, are described to the origin. Okay, so if this is in the origin, this element here, okay, the distance come from the origin. So if I want something from the center, I need to offset a little bit the origin. And also because I've said that I want something between, so with a distance of 1, okay, and basically 1, this is 1, this is my distance. You know, my body is 1.8 for example, so this is basically 1. So if I want something bigger, for example, I could say let's find a sign distance field with a sphere with a value of 2. Maybe I need to clamp this value a little bit. if I use that, I cannot get a value from 0 to 1. Those much value, let's use this value as the albedo. I think the value is going are bigger than 1. Seriously? 0? Nah. Maybe it's returning me a negative value, which can be possible, of course. Let's try to get the absolute value only and try to check that. Okay. So I think this was the problem. But something is quite interesting. If I say 2, for example, where is my texture? Which one did we use? I think we've used this one. Zero one, 1. We have some kind of a repetition into it. So let's try to move a little bit to the center. Okay, so let's say the center would be something like that. Float 3 0 0 0 minus this. So on the vector going from the center to, okay, so of course my center is not at 0 0, but let's put a center and let's try to find out. If I put a little sphere here on 0 0 0, let's put 0 5 0, oops, I haven't put the value here, 0 5 0 5 0 5. And if I want something here, yeah, 1 might be a good option. Okay, so I want a vector going from this to this. Not sure about that, but let's try that. It might be the inverse. And if I'm not taking the absolute value, so this seems better for me. So the center is here, and now it seems to be better, as you can see. 0 and it's reached 2. when we divide it by 1. Okay, so when we take only this value, if I want a distance of 2, but of course the radius might be the size of our guy divided by 2. Okay, let's try the ramp now. And now you see, and you see that we reach a point here. So okay, so now you can see it. So our ramp look like that. You can go to this, so I think it's better if we put the inverse here. Maybe we could take the fractional part of this one to check. Okay, so this is it. Clump between 0, 1. We have the repetition, of course. I think we'll keep this because we need to or going white. Maybe it's better to going white. What do we want? Let's try to see some stratification into it, so let's do something like that. Then strat might be too much, let's say 4 for example. Okay, so let's go back to 1. Something we can try is also offset a little bit this by the time, just to have some quick animation on the ramp. Now this is good. So if we multiply this by 2, I think it would be too much. Maybe multiplying by something like 1.25. My idea is to simply offset a little bit, not too much, but having something we can see. So this is great, and we could add, of course, a little bit of luminosity directly into it. So yeah, this is the main idea. So now we could simply take this in order to offset a little bit the color from the ramp, and we can go back to this. In the air tonight. Okay, there's some kind of subsurface lookalike, which is kind of interesting. Okay, let's get rid of the body right now and just try to focus on the final render. Something that might be interesting is adding a little bit of lights directly into it, so using some kind of step. So let me try. Let's try to say O dot emission would be, let's say, just equal a step of the SDF if it's bigger than 0.9. Let's check what's happened now. This would be 0.1, so we would add a bit of light directly into the elements. Yeah, you notice that. And of course I've set it up with that, but I need to use the animated ramp. So let me animate it directly here, so we could use and now it's not animating. Oh yeah, I haven't used the fract on the proper part, so it's a fract of a fract. So let me just change this, because we are going up than the value. So let's say float animated sphere SDF, which will be equal to the frac of our sphere SDF minus the time. So this is the proper way if we want to be. So we could say something like that, and now I could put it here, and this might do the trick. maybe 1 or 0.25 might be enough. I know that. To match with the animation. And we could use also a smooth step, because it's always kind of interesting to have something like more, not more glowy, but with a little bit of fade inside of it. Okay, I think we have it. We need to change a little bit some of the elements. For example, this part. I think the glow is too, not the glow, but I need more blur on the it's interesting, but too much. Yeah, something like that. So yeah, I think this is the end of the stream tonight. We've reached a point where I'm quite satisfied with this animation. We could also try to tweak a little bit some of the value, of course, as always. For example, saying we want something going from, let's say, only not 2-second animation per sequences, but 4. So 1, 2, 3, 4, 5. So check, and then it will wait a little bit before growing. But I think it might be good with maybe 2.2 is 2 is okay for me. We have something really interesting. It's quicker and three, for example. Let's try that. I'm always tweaking the value at the end of the stream. 3.5 might be too much time. So yeah, maybe now we can change. If we want to match the fact that when it reaches the head, it will collapse. This more question of timing. So maybe I could say something like that. Just scaling this a little bit. Not sure about that, but I think I would need to to scale down and not to scale up. So 0.25 for example. There are 6. Let's try that. We're near the good result, but let's try that one. Let's try that. Okay, both 0.5 also. in fact I'm changing, but it's not quite good. I'm changing this, but this is not the part where I need to change. It's more like that. It's more the time I need to change. I need to slow down the animation, not scale the sign distance field. Okay. So after that, let's try that, and let's try to scale up a little bit this, and hope it will do the trick. Perfect. It takes some time, and after it reaches, it's collapsing, and then it will go back. Okay, so that's the end of the stream tonight. I'm quite satisfied with the results, so I hope you like it, and see you tomorrow for a next stream. For another one, I don't know which one we will doing. Maybe the donuts, as someone has suggested. So I hope you like it, and see you tomorrow, guys, and have a good night. Bye, everyone.